Azure Kubernetes services. So we have to study some theory about it. So are you guys ready?
Yes.
Yes, Manoj.
Okay. So Kubernetes is suitable for microservice architecture. So first thing you have to understand is microservice architecture. That I've explained you so many times. So I want it from you guys. So what is microservice architecture? So many times I explained, right? Who will tell me?
Um, so Manoj, it's basically like a framework or an infrastructure where if instead of the application running as a whole, the entire application is divided into small segments or small micro services so that the functioning of the services becomes easier and it is easier to track those services also to keep monitoring those services from time to time. Instead of the entire application breaking down, you can have different teams taking care of uh, taking care of the different microservices within the application.
Like
Hmm.
example of passport office.
Yeah, correct. Like or an airport also. The passport offer
Yeah,
was
I
the
gave you
best
the example
example. Yeah.
passport that instead of
Yes.
having one big service, you'll
Yeah.
break it into small service called as microservice.
Services.
Okay.
Microservices.
Yeah. And Kubernetes works with containers. Containers also we have studied. So what is a container? Yes, Kev,
Container
what is
is
a container? Kev?
con-
Yeah, Kev. Yes, what is a container?
It's lightweighted, can say, uh, lightweight like machines or the application,
Hmm.
uh, which has uh, which has only libraries and dependencies. It can be transferred easily. Uh, it does not has the operating system, but use the host machine operating system. So
Yeah,
it's
it is
a
a,
small.
it's like a virtual
application
machine
settings.
without operating system, you can say.
The
Will use the operating system of the host, right? So that's why it's lightweight because it has only application uh,
settings.
information and everything related to application, all application dependencies and everything. So that is a container. Okay. It does not have any operating system. So it will depend on the host operating. That's why we say it's a lightweight. That's why we say it's a lightweight. Okay.
The the
Right? Yes, yes, tell me.
you have mentioned that it have only a common operating system. That's why
Speak loudly. I can't hear you, my dear. Speak louder.
you have mentioned earlier that it have only a common operating system. That's why it take less time to start and easily deployable.
It does not have any operating system in that.
Common operating system.
Common means it is using the host operating system. Host means the
Stop.
hardware on which it is installed. It is using the operating system of that host. That's why it's called, that's why we say it doesn't have operating system. So it doesn't have to process. Virtual machine, if you start, then first the operating system has to start and then the application will start. It is time consuming. But container is not like that.
Okay, so it's contain only the host operating systems.
Only the, it contains only the,
Host operating system.
huh?
Host operating
Application,
system.
application, my dear, application. Contains the application.
Application settings, yes, sir. But the operating system you're talking about, it takes only the host operating system.
हाँ तो होस्ट मतलब उसमें नहीं रहता कंटेनर के अंदर कोई ऑपरेटिंग सिस्टम नहीं है होस्ट मतलब क्या फिजिकल सिस्टम फिजिकल वर्चुअल मशीन कैसे बनती है फिजिकल सिस्टम से बनती है ना
Yes.
तो वर्चुअल मशीन एक्चुअल में कैसे बनती है कि आपका एक बहुत स्ट्रॉन्ग फिजिकल सिस्टम है, उसमें आपने लॉजिकल सिस्टम बनाया, वो वर्चुअल मशीन हो गया, राइट?
Yes, sir.
The whole cloud technology is about that only कि फिजिकल वर्ल्ड कुछ अलग ही है और वर्चुअल वर्ल्ड कुछ अलग ही है, सपने वाली दुनिया है।
Yes, sir.
फिजिकल वर्ल्ड में आपके 10 होस्ट होंगे, 10 होस्ट में 10 एक्चुअली हार्डवेयर होंगे, मशीन्स होंगे, जायंट मशीन्स होंगे। और लॉजिकल वर्ल्ड, वर्चुअल वर्ल्ड में you may have 100 virtual machines made out of those. So कैसे है, what is the physical reality we do not know, that is virtual machine, virtualization is that.
Yes, sir.
Getting me?
Yes, sir.
So but you have to understand that virtual machine is taking the resources from the host. Host matlab some hardware, some actual physical system, that is host. और virtual machine में अलग से ऑपरेटिंग सिस्टम होता है। तो जब हम कंटेनर बनाएंगे तो कंटेनर में ऑपरेटिंग सिस्टम नहीं होगी, वो होस्ट जो जहां पर भी वो कंटेनर है उसका ऑपरेटिंग सिस्टम यूज करेगा। So that's why it's lightweight. Lightweight means उसकी प्रोसेसिंग कम लगेगी। It will have less processing power. That's why it's called lightweight. Got it?
Yes, sir.
Yes, sir.
Sir,
हाँ,
can
yeah,
we
tell me.
consider can we consider container as an application too also, because it is like it is installed, we can say, in host.
Sorry, what? Come again, what you're saying?
Can we consider a container as an application because it is installed in host?
Yeah, it's application. Container is application only. Only application.
Yes, sir.
It
Okay.
doesn't have any operating system, only application.
Yes. Microservice.
Now 100% is clear for me. Thank you.
Yeah. Right? 100% clear?
That container is
Yes.
nothing but a microservice only. That's a right, sir.
Hmm?
It's a microservice only. Container.
No, container is not microservice. Microservice is architecture. It's a way of designing a solution, a software solution. So one of the microservice component, microservice means a small service, right? Small application that you put in container. So it's very suitable. The containers is a suitable architecture for microservice.
Let's say container is a platform for
Containers are the platform for managing the microservice because one container can have one microservice running. Okay, and it will give you fault tolerance. You can have those facilities like span out, scale out, and scale in. That means if one microservice is getting too much load, it can scale out. It can create its replica container. So 2, 2, 3, 3 containers, which will be giving same service will be running.
Yes, sir.
You're getting me? So that is the beauty of this. Clear?
Yes, sir.
Okay. Now,
Sir, another question, sorry.
yeah, sure.
You've been saying all the time container takes the operating system of the host. That gave me like now an idea that the container is only installed in host, which is physical host, you are saying.
Hmm.
Is it like that, or we can also install the container in virtual machine?
Yeah, good question. Virtual machine is also machine. No, you can have container in virtual machine also. No problem.
Hmm.
In that case,
Okay, that
virtual machine
means
will work like a
then-
host. Virtual machine will work like a host in that case. Okay.
Okay. In this case also, we are saying that because we know that one of the
That's why we are
features of
using the word
one of
host. When we say host means it can be virtual machine, it can be
it can be physical
normal
host.
physical system like that.
Okay. No, now also what we came to know that one of the feature of container, scale out and scale in.
Yeah, container
That
can give you all those facilities. It can scale in, scale out. It can also do load balancing. We can also give some health status. There is a controller where you
so,
can say
so
that at least 3 applications should be up and running. Okay.
mm,
So if one container fails, automatically it will create another replica.
Yes, sir.
mm,
So it really it's a beautiful way of managing the applications. So that's why the whole world is mad after AKS, Kubernetes service, because it helps you to manage the containers.
mm. Then, sir, the virtual machine or the host which we want to install container in it, that if we planning to do this to do so, like installing container in the virtual in the host, we have to make the host with high configuration. Is it like that? Because
Yeah,
container
normally, but
it can be.
see if you make it,
Mm,
if you make these virtual machines as a standalone, like you are making or I am making, normally we end up using only one physical system, right? One powerful physical system, and then we are going to make the virtual machines on that. But cloud technology is not like that. Cloud technology, there are many physical machines. Maybe there are
mm,
10 physical machines or maybe 100 physical machines in a data center.
yes, yes.
But there, with that 100 physical systems, maybe you can make maybe 10,000 virtual machines. Getting me?
Mm,
Yes, sir.
yes, yes.
Because it combines the power of all the systems. Like now I have on my desk, there are how many? 2 laptops, right? One
Mm,
laptop has 32 GB memory, other has 16 GB memory. So total how much
mm.
memory?
Okay.
48 GB.
Yeah,
Yes,
48.
sir.
Mm,
And one laptop has 4 CPU, other has 6 CPU. Total how many CPUs? 10 CPUs. So total
mm.
power is 10 CPUs and 48 GB RAM.
48 GB RAM. Yes.
So with that, I can make now maybe 5 virtual machines. Five CPUs. I will
Yes,
10, no? 2 CPUs I'll give to each virtual machine, perhaps, right?
yes, sir.
And I will distribute the memory also according to my requirements.
Yes, sir.
So it's like that.
Scale.
So cloud technology is like that. It will combine the physical resource. It makes a pool of virtual machines, pool of memory, and then it will cut it and cut the slice and give you. How it is doing, we do not know. That is cloud technology. That is the physical world is different, but logical world is as per your imagination.
Yes, sir. No doubt.
So this is the abstraction which the technology creates. Okay, and same thing happens with this Azure Kubernetes services. When we work with the containers, same thing is happening. There also we have abstraction created. So
Mm.
physically, there may be something, and logically, it gives you something else. Logically, it will just you have to just specify that okay, for this application, I need say 5 vCPUs and I need 16 GB memory. So it will make it for you.
Mm, mm,
You have to just tell the system that I want. You forget what hardware is there. You just demand, I want this specification. It will create that world for you. And it will manage very beautifully in the background screen. So you have to look at it like that.
Next, sir, it is open source.
Hmm. Okay, you have to look at it like that. Clear, everybody?
Yes, sir.
yeah.
It's the same.
Huh? I did take my lunch today. I was out. I ate outside only, so my tiffin box is as it is.
Yes.
There's some buttermilk which I'm drinking.
That's good, sir.
So I thought at least I'd have that.
Yes, sir. You need a lot of energy, sir. Now.
Yes, little by little.
Yes, sir. It
Okay. Or
will. It's all
gain some energy.
Yes, sir.
Okay, now see this is microservice architecture we have seen before, right? See that microservice architecture is also creating an abstraction. You can see so many services, right? There's API gateway. So the client is talking to the services through API gateway. When client is not aware, like which service is where, it just requests some service.
What happens in API?
The API gateway will direct it to the proper microservice and get the job done.
What is like integrated in API gateways? What things are there? Like, we call as API. Like I understand that you are going to wash. Understand that there is some URL things are there. They are integrated into that. So by that way, like it bifurcates the request, right? From there.
What
API gateway could be the server, could be anything like that.
API gateway, no?
Yes. Those are the like link URL links,
Yeah. Serverless architecture, just
serverless.
REST API. REST API means just give a URL. With the URL, it will access some service.
All right.
This is how the microservice architecture works. Again, abstraction is created here. Okay. Abstraction means what? Hiding the complexity.
Making it very simple.
Simple, yes.
Only DevOps.
DevOps is managing all this.
That's the behind that.
It is Niaz. It is Niaz.
One
And this is Amin. This is Amin.
integrated. Sir, do we have a labs for this function?
Wait a minute. Wait a minute. There is normally no lab, but I am thinking to take one lab because just only for Niaz, just to make him happy.
Yeah.
Are you guys ready to do lab for this? You have time, extra time. I'm
Yeah,
just stretching
lot
the
of-
course so much, right? You're saying, sir is
Yeah.
going to teach Azure for the whole year, right? It looks like.
I want index.
Wait. Right? Everyone clear?
That's right.
Now, so here just written here, what is microservice? Microservice architecture. Mudassir, are you there? Mudassir is there or not?
No, sir, he hasn't joined.
Why he hasn't joined? Arafat is there, na Arafat. Sanjay is also there, but Sanjay is not talking today. Arafat, are you there? Arafat? Arafat,
I think,
I can't
yeah, I
hear
think,
you.
yeah, he's there in the meeting.
He's there, but I doubt this boy what he does. Lungi dance, you know.
Oh, yes, sir.
Yes, why don't you respond, my dear?
Hello. Yes, sir. Actually, I joined from mobile. I'm outside.
Okay. Okay, so microservice architecture consists of small autonomous services. Each service is self-contained and should implement a single business capability within a bounded context. एक independent service कुछ ना कुछ एक independent चीज करना चाहिए वो service. Okay? जैसे front end है या back end है या database है ना वो करे.
That's right.
Then we have how it works. Let's see how it is working. So clients will communicate using API gateway. Clients will communicate using API gateway. It creates an abstraction. The service will be scheduled on a particular node based on the resource requirement. It is done with the help of management orchestration. Kubernetes is a suitable platform. So clients who are using the Kubernetes, they are unaware of the internal architecture. They don't know that the containers are working or containers are working or containers are working. They have no idea. They will just submit the job. They'll communicate whatever service they want. They will take it through API gateway, right?
Sir.
And the services are running in maybe some containers in particular node. Node means a particular system. Okay. Yeah, everyone.
Yes, sir.
Okay, I'll go to the next slide. So this is Kubernetes cluster architecture. Cluster means what? Cluster means a group of computers. It's called cluster. What is cluster? A group of systems. Group of machines is a cluster. Each machine is called as node. See node here, node like that. So basically it has got two things. One is control plane and other is nodes. So this is the architecture of Kubernetes, cluster architecture. So Kubernetes is an engine which we can use it for managing the
Machine.
uh, containers. In containers, they are created in the node. Node means your actual systems, right? So we have to study this. This gives an overview. Just take a picture of this. So very well, you can see there's a control plane. In control plane, you have API server, etcd, controller manager, scheduler. So API server is something which will interact with the clients. So clients will talk to the API server to get the job done, right? So it creates the abstraction. So this guy will take the instruction and then he will schedule things, right? It will send it to the proper system. It will work with this etcd. You know what is etcd?
Yes, sir.
What is etcd? Yes, sir.
Sir,
Yes, sir.
it's,
Yes, tell me.
sir, actually, it's a database which keeps all the in keep value pairs, all the information. It is
What information?
whatever the suppose the container is there, node is there. So that information it keeps. Exactly where it is.
etcd is the, yes, it's a brain of the Kubernetes, you can say. It contains all the information, the knowledge about the Kubernetes, like which nodes are working, what container is working where. The entire thing is stored there, etcd. It's like a brain for the Kubernetes, etcd. etcd is a Linux term actually. Kubernetes actually is made of Linux. It was initially made by Linux for Linux, and but now even Windows containers are running.
Yes.
But initially it was made for actually Linux. Initially it was made for Linux, right? Now the things have changed. So this is etcd. It's a controller manager. The controller manager,
Sir,
yes.
ATCD means it has whole information about Kubernetes, right? Kubernetes.
Yes, it's a brain. It's a brain, uh, gray matter of the Kubernetes is in the etcd.
So in short, we can say the brain of Kubernetes is called
Yes, yes.
etcd.
Yes, correct. So that's why it's
Okay.
two ways. See, there's two-way things. Bidirectional, they communicate. So API server also communicates with the controller manager to get the things done. Scheduler. Scheduler will interact with the nodes actually, right? So, and also this node, see the number of nodes. cluster. So first of all, you understand cluster is what? Cluster is what? Collection of machines,
Group of machines.
group of machines. Cluster is nothing but group of machines. Okay. So are you guys? I was just wondering. I want to take one more test. So are you guys ready for the test?
Yes, sir.
Yes, sir.
All
Yes.
right.
All right. Yes.
Yes, sir.
Sanjay and Arafat.
Yes, Manoj. Yes, Manoj.
Mudassir is there.
No.
On Saturday.
Yeah, I want to take. But are you guys happy? I see the course is getting extended a bit. So are you guys okay with that? Like, I'm just. Hmm?
See, honestly for me, Manoj, that's not a problem because
Right
as
now.
long as we are getting something to learn, so the duration is not a problem.
Yeah. Yeah, it all depends on the
Sir,
students like you because you guys are taking interest. So I'm also interested to teach a lot. I want to give
Correct.
extra. It's like that.
Yeah, correct.
sir, actually for me, the course is going so fine, but I have only one request. Uh, I don't know that, all practice things, all practice sheet.
Hmm.
I want that plus because actually I did not do practical part by myself. Like, at the beginning I used to do practical part by myself all the time when
Hmm.
I get any practical. So now I just got lost because I don't know what things that I have to practice now. I want the practice sheets. That will be better for me actually. That's it.
Yeah, those labs you can practice again. Last Saturday, I that's why I allowed you to practice one more
Th-
time, right?
There,
I can do
but
that. I can give
uh,
that practice sheets again so that you can practice, recollect things like that. So, and see, the thing is, we have created a one more account, no? So you can practice again.
yeah,
Yes.
actually I got I don't have the practice sheet that I lost them.
I'll
Some
put it
some
in the
parts.
group. All practice
Uh,
labs, I'll put on the group again if you want.
Yes, sir.
yeah, yeah,
And if,
please. Thank you, sir.
sir,
Yeah.
and the account too. Account and password.
Account and password. That's right. Yeah, fine.
Yeah, account and password. Yeah, this Harsh is always helping. So it is his account now. So we are enjoying his card now. So you can always, like yesterday, I used it for one of the students, right? One more student, he was doing Azure. So I helped him doing that with that. So you can
Yes,
always,
thank you,
because
thank
he
you,
has
thank
made
you,
some
Harsh.
code, some code is there. So, but only thing is, Harsh is available only after college hours. After 6 p.m., you request him, perhaps then he can support you. But if you trouble him before that, then he will trouble you. Okay.
Mhm.
Harsh is,
So
Harsh, our student, favorite student, Harsh.
Yes, sir.
Look at his smile, his specs. You will not.
So Ibrahim, actually, there are some things which I haven't revised since I don't have my personal laptop with me and I'm out of station. So I was thinking of doing some practice in the month of March, and I had planned probably to all. I mean, guys in our WhatsApp group, whoever has time, sometimes we can connect on Sundays also whenever possible. And I was thinking of uh, renewing the Azure subscription, somehow arranging credit card and stuff, because even I haven't practiced in the month of January. It was a little hectic for me. So we can definitely connect on Sundays also.
But no
So
need
this,
to take any card. No, you can use this card now. This card is available at the moment, right? You can use it
Yeah,
always.
yeah. For now, I mean, I was thinking, I
Hello.
mean, just in case, since I don't have my laptop with me right now,
Hello.
if I'm not able to practice at the moment, I was thinking of connecting with the group members in the month of March also. Whenever anyone wants to join, we can have some. We can have a call on Sundays also
Yes.
whenever these people are available.
Yeah, it's fine. It's fine.
Yes, yeah.
Yeah,
Yeah,
Fine.
just
very
for
good.
practice,
Yes,
we
yes,
boys
tell
can
me.
connect on Sundays sometimes for an hour or two.
Okay.
Yeah.
Yes,
but
yes.
not on 23rd. Na?
I mean, we can plan a week prior, and
Yeah.
whenever everyone is okay with it, we can connect on Sundays
Mm.
for 1 or 2 hours. So I was thinking this not as a part of the class, but something like a self study which we can do on our own. All the
Okay.
guys, we can do that. We have the WhatsApp group to coordinate, so we can do it that way.
Yeah, we can.
त्या तू किती लोकांना द्यायची एक्झाम? मला काम करा, तुम्ही मला आहे ना कुठली एक्झाम द्यायची ना व्हॉट्सअप करा तुमचं नाव सगळं. कोणा क्लासमध्ये मी फोन करतो तुम्हाला एक्झाम नंतर काय करतो. व्हॉट्सअप करतो फक्त व्हॉट्सअप करतो. हा कुठली एक्झाम पाहिजे काय पाहिजे. Yeah, so please practice. Sorry, I was got busy in the call. So practice, and that's why I would like to take a test also just to check where you guys are.
Which topic, sir?
Topics I'll give. Last time I took AD and storage, right? You were not there that time.
No, not that.
Yes, correct.
So I would like
Networking
to.
is remaining.
Okay, networking I can take on subnetting networking. Are you guys ready for that?
Yes, sir.
Subnetting networking. Can you guys prepare? Yes, everyone.
Yes, sir. Subnetting and networking.
Yes, sir.
Yes, sir.
Yeah, prepare that. So we will.
Also.
Application gateway, should I include in that load balancer and application gateway?
So, two topics.
Huh? Which topics?
Subnet.
Networking topic. Okay.
Okay.
So be ready. Saturday, shall I take it?
Yes, sir.
All right, sir.
Study and come. Just don't come like this.
Yes, sir.
You must study and come.
Yes, sir.
Okay. If you come like this,
You're trying.
I'll send you out of the class.
I'll be. I'll see.
Okay, so here you can see that here the description is given for this particular components of that control plane. To study this properly and also see next batch, I would start with the security measure, you know. So if next course will be security measure. So you can think about that also. So special course in security.
So this assured course
Sorry?
is, so this course is ended here.
It will end soon. Now we are at the last stage. We are not, we are almost there. Okay, now, so Cube API server. So API server is how the underlying Kubernetes APIs are exposed. This component provides interaction for management tools such as kubectl or Kubernetes dashboard. So actually to control the Kubernetes, you require to use this, some management tools are there called kubectl or Kubernetes dashboard. So it actually interacts with the Kube API server only. Okay, so that guy responds. So people are interacting with the Kubernetes using the kubectl or Kubernetes dashboard.
So in the background, Cube API server is already there in the Kubernetes.
Yes.
And for support, we are using kubectl and Kubernetes.
Yes, correct. That's right. Okay. Then we have etcd.
All right, sir. So,
Yeah.
just the network is just suddenly just got dropped down.
Yeah, what
I
happened?
didn't actually. I didn't.
Voice is breaking, my dear. Your voice is breaking.
Yeah, I know, sir.
Yeah,
I
tell me,
said
tell me.
suddenly the network is dropped down. So I didn't hear last things what you were saying about this. What you are. This is slide. I did not hear what you are saying about it.
Yeah, I'm talking about a Cube API server. Cube API server, you know, if you want to operate the Kubernetes, we have something called as management tool called as kubectl. kubectl or Kubernetes dashboard. So when we work on that, behind that we have this API server. The API server is the engine behind that. So whatever commands we are giving, it is actually going to the Kube API server, which is there in the control plane. Okay. So that guy will answer all your queries. That's what I'm saying. It is going to respond to all your queries.
To keep simple, actually, we install them locally. Keep simple.
Oh. I have one exercise. We'll see. I'll give you one exercise on this Kubernetes.
Yes, sir. Only one.
Yeah, बस हो गया ना. बाकी तो दूसरा क्यों
Everything will be covered.
तो करें. रो मत पुष्पा. You know that's dialogue.
Okay, got it.
Then etcd, I already told you to maintain the state of your Kubernetes cluster and configuration. The highly available etcd is a key value store within Kubernetes. So it is like a brain for the Kubernetes. So it shows all the configuration, all the information about the Kubernetes, right? उसका बैकअप भी लेना पड़ता है. बैकअप लेते कि etcd का बैकअप लेते. Unless it is a
Disaster recovery.
disaster recovery है ना.
बनाया है.
है ना. हाँ फिर ठीक है.
हाँ. तो ऐसे
Because it's the brain. It's like if it gets lost, then it's like everything is gone. It's like the person has lost memory. You know what happened to him. It will be something like that. Okay. Then Kube scheduler. When you create or scale applications, the scheduler determines what nodes can run the workload and starts them. So actually, as I said, you submit the application that you say that I want so and so memory, so and so CPU. So the scheduler will talk to the nodes and find out that where this container can be created, where this container can run. Okay. So which is the most suitable place where the container can run now for this particular requirement. So scheduler is going to decide that. The scheduler is going to do that. Getting me? Yeah. Then we have Kube controller manager. The controller manager oversees a number of smaller controllers that performs actions such as replicating pods and handling node operations. So controller manager is like executor, right? Oversees a number of smaller controllers that performs actions such as replicating pods. Replication of pods मतलब क्या?
Replicating for it checks the desired action. If it is available over there, so it checks like if, suppose if we give a command using a kubectl, right? Start the pod. Okay, so the controller manager it will check the desired. Like if it is stopped, so it will start the pod.
Right.
If the information matches, then it won't do anything. Only
Okay.
the differences which are there and it requires to be changed.
So actually main component here is pod. POD pod. One pod can have one or more containers, sorry. So actually Kubernetes का जो computing component is called as pod.
Yes, sir.
Pod का कोई full form है क्या?
The
There is
pod
no-
was always-
Pod ही है, उसको नाम pod ही दिया
pod
है.
is-
Right? So it creates pod and one pod can have more than one container. Usually one pod has one container, but you can have many containers in one pod. That is possible. Okay, so Kube controller manager, it interacts with this nodes. Okay, it interacts, it is handling many other controllers. So it's like a execution engine, right? It will execute it, whatever commands have to be given to the nodes, to the pods, it is going to do that. Right? So that is how this guy is working. So this particular thing which we just saw, this control manager, control plane. So every Kubernetes cluster will have one control plane. So when you make a case, so you have a control plane there. Hmm?
मास्टर स्लेव आर्किटेक्चर कंट्रोल प्लेन एक मास्टर के जैसा वर्क करता है और नोड जो है पूरे नोड मशीन
Yes, master slave. You're right. Control plane is managed by the Azure, and these nodes are managed by the customer. You will decide how many nodes you want. I think. Right? Clear, everyone? The components of the control plane is clear. Okay. So Kubernetes is a very hot topic. So a lot of people are using Kubernetes. Okay, that you have to understand. I'm thinking to design a course which is two things. For the next journey, I'm talking to you. One is security and other is DevOps. Combine the two. DevOps architecture, DevOps and Kubernetes, this security.
DevSecOps.
Hmm?
DevSecOps.
Hmm. So like this, get more benefits.
We have to study for security, then we have to go to DevOps.
No, not like
Security.
Azure. See what you have studied now. The Azure is the first course. The course which you're studying is the very powerful course that helps you to do any other course, right?
Yes, sir. Okay.
On cloud, in Azure cloud. So I'm going very deeply in this because once you get hold on to this subject, then with this only you can get good jobs. You can do a lot of things.
Yes, sir.
Plus, if you want to do anything extra in cloud, then this is the starting point and the best thing which one can do.
Yes, sir.
Because even if you do data science or anything, it requires Azure cloud and Azure services and things like that. So it all starts with this. Okay, now we go to Kubernetes node. Let's see what are the components. First, let me explain you this. See here, we have container runtime, you have container, you have kube proxy, you have kubelet. So in a node, what all things you have? You have kubelet. Kubelet is talking to the scheduler, means it is accepting the commands from the scheduler. One can make it out, right?
Yes, sir.
Then, so it's a communication. It communicates with the control plane. Every node should have one kubelet, which will communicate with the control plane, which will accept the command, high command, whatever command is happening from there, it will accept it. So see, what they have made is the abstraction again. Understand the abstraction here.
Yes, sir.
And we have kube proxy. This kube proxy will give you, it's for networking.
Yeah.
It's for making connection, network connections. And containers, you know what are containers, right?
Yes, sir.
And you have runtime. What is container runtime?
Sir, it's a Docker engine.
For execution purpose, executing the code and like that. So that's what
Actually, it's a
container.
Docker engine.
Hmm.
Means it is created by Docker engine. It's running executing those things.
Yeah, it's a running component basically. So these are the four things: kubelet, kube proxy, container runtime, and container.
Actually, it should have the pod now over there instead of content. But just to understand that
So pod and container, you can say it's synonymous because normally one pod has one container, normally speaking. That's why they're given like this. Okay. Yep.
so
Getting
yes, sir.
that's all.
Yes, sir.
Yes, sir. Now, control plane managed by Azure. ये तो हो गया. This kubelet. So the kubelets, the Kubernetes agent that processes the orchestration request from the control plane and scheduling of runtime running the requested containers. So that's what I told you. The kubelet is the communication. It is accepting the communication of the control plane. Processes the orchestration request. Orchestration means what? Always this word orchestration will come. Orchestration मतलब क्या होता है? What is the orchestration actually here?
Many containers.
So it's basically how you manage something.
Sorry?
It's basically how you manage something. Like if we look at an orchestra, what happens is you manage what will happen when and which action needs to be performed by which person. So that's how you orchestrate something.
The sequence, the sequence and all that thing, right? How first do this, do that, and arrangement, basically arrangement. Okay. So this control plane is like a master, is sending commands to everyone. So basically it is doing the orchestration. It is deciding which application will run where. Okay, like that. So kubelet is a component which is talking to that. Then kube proxy handles virtual networking on each node. The proxy routes network traffic and manages IP addressing for services and pods. So kube proxy is your network component. Proxy, it's called proxy because again it is a abstraction. Okay, so it gives you a feeling of network card as if you're connected to virtual networks and all that thing. So this is why kube proxy. That's why it's called as kube proxy. Okay, then we have container runtime. So container runtime is what allows containerized applications to run and interact with additional resources. Such as virtual network, storage. So these containers, they are like machines only, right? So they can connect to storage. They can. So it's an engine which run the code. Okay. So AKS cluster is using Kubernetes version 1.19 plus for Linux node pods. Use container RD as the container runtime. Beginning in Kubernetes version 1.20 for Windows node pools, container RD can be used in preview for the container runtime, but the Docker is still default container runtime. So Docker is the default container runtime for the Windows workload. Okay, AKS clusters using prior versions of Kubernetes for node pools use Docker as the container runtime.
Yes, sir.
So container runtime is the Docker.
Yes,
You
sir.
rightly said. It's the Docker.
Default.
Default it's a Docker.
Yes, sir.
तो रन टाइम होता क्या है मतलब क्या करता है वो
सर वो कुछ भी जैसे रन टाइम नहीं होता अपने एप्लीकेशंस का वो रन करता है ना तब उसमें जैसे लिनक्स हो गया या फिर कोई भी विंडो हो गया
रन करता है and interacts with additional resources.
Yes, sir.
It's an engine.
There are node and node pools, sir. In that, it is connected to every pod, means container. It's connected to the node pool. So
Node
pool. In Kubernetes, there is a node pool. वो node pool में वो connected रहता है. तो उसके थ्रू वो रन उसमें मैच करेगा तब मेरे को नहीं रन या फिर उसमें वो एरर बताता है कि बैक ऑफ क्या बोलते हैं उसको लूप बैक ऑफ वो एरर बताता है उसमें या फिर कोई इमेज होगा वो कंटेनर वो फेच ही नहीं करेगा वो रन नहीं होगा
एक्चुअली रन टाइम मतलब एप्लीकेशन एग्जीक्यूशन के लिए लगता है फॉर एग्जीक्यूशन व्हेन यू से रन टाइम मींस एग्जीक्यूशन फॉर एग्जीक्यूटिंग द एप्लीकेशंस इन द कंटेनर द कंटेनराइज्ड कंटेनर में जो एप्लीकेशंस को रन करने के लिए कुछ तो लगेगा ना यू नीड समथिंग टू रन टू एग्जीक्यूट जैसे जावा के लिए जावा रन टाइम रहता है जैसे इसके लिए रन टाइम okay so it's execution so it's only one run time which is docker here which will run these containers का engine है वो right so here you can see so many containers, right, in one node. This kube proxy is actually connecting to the Azure virtual networks.
This I need to understand.
And container, you can see, is also accessing disk and Azure files, the storage, accessible storage and everything.
It's कोई use करेगा
Hmm?
जो डिस्क ही यूज करेगा वो कंटेनर जो रहता है ना उसमें एक्चुअली हम लोग वो करते हैं मेंशन करते हैं हम लोग उसका फाइल रहता है डिप्लॉयमेंट फाइल रहता है सर्विस फाइल रहता है जिसमें प्रॉक्सी वो सब चीजें रहता है तो ये कंटेनर रन टाइम उससे मेंशन करते हैं सब तभी जाके रन करेंगे
वो तो आप जो दोगे वो कंट्रोल प्लेन को देंगे. कंट्रोल प्लेन विल सेंड द विल मैनेज दिस ऑर्केस्ट्रेट दिस. इसमें आपका कुछ नहीं रहेगा. आपको जो भी देना है YAML फाइल में देना है. जब डिप्लॉय करेंगे ना एप्लीकेशन तो आपको यू हैव टू डिप्लॉय थ्रू YAML फाइल. यू हैव टू से कि दिस इज व्हाट वी वांट.
इसमें सर नोड टूल बनाना पड़ता है अगर विंडो का रहेगा तो विंडो का बनाना पड़ेगा क्रिएट करना पड़ेगा और लिनक्स का रहेगा तो लिनक्स का करना पड़ेगा और ये उसका नेम है उधर फाइल में मेंशन करना पड़ता है नोड सेलेक्टर जो होता है वो तो देंगे तो सर
ओके. तो नोड पूल्स वही आ गया. नोड पूल्स इज द कलेक्शन ऑफ सिमिलर नोड्स. नोड पूल्स बनाने के बोल रहे ना आप.
यस सर
So इस क्लस्टर हो गया ना नोड पूल्स. मतलब वही नोड पूल्स इज व्हाट कलेक्शन ऑफ नोड्स. इट्स कॉल्ड नोड पूल्स. सिमिलर नोड्स. नोड पूल बनाना पड़ेगा ना तभी तो वो बनेगा. वो कस्टमर मैनेज होता है ना. You have to create node pools.
यस सर
Node pools बनाया आपने.
प्रैक्टिसिंग के टाइम पे बनाया था जब मैं कुबरनेटिस का देखा उसका स्ट्रक्चर तो ऑलरेडी बना हुआ
Then pods. See, Kubernetes uses pods to run an instance application. So normally there's one-to-one mapping between one pod and one container. I mean, but we can also have one pod having many containers. एक pod में हम ज़्यादा containers भी दे सकते हैं.
एक ही कंटेनर रखने का फायदा होता है अगर ज्यादा रखते हैं तो उसमें थोड़ा कंफ्यूजन होता है तो मोस्टली एक पॉड में एक ही कंटेनर रन करें तो अच्छा रहता है थोड़ा सा मान तो उसमें नेटवर्किंग का वो जो कम्युनिकेशन में कुछ प्रॉब्लम हुआ ना तो फिर वो प्रॉब्लम होता है फायदा
So when we create a pod, we can define the resource in terms of CPU and memory. That's what I told you, right? Pod create करने के लिए हमको it's again virtualization, it's abstraction. Just you say मुझे इतने CPU चाहिए, इतने memory चाहिए, right? You can set the upper limit for the same. Pod is a logical resource, but application workloads work on container, right?
यस सर
So pod is like creating a resource. Resource मतलब कितना CPU चाहिए, कितना memory चाहिए, वो हम decide करते हैं. जब हम pod की बात करते हैं तो हम this is what we decide. All right? Deployments. It defines the number of POD replicas to create container images to be used and attached storage. It defines the number of pod replicas to create container image to be used and attached storage.
यस सर सर तो डिप्लॉयमेंट
So deployment जब हम करते हैं तो ये सब हमको बताना पड़ता है कि हाँ कितने pod replicas चाहिए to create container image to be used and attached storage. Image कहाँ पर store रहता है?
और ये हेल्प के थ्रू ये पूरा जितने भी फाइल्स है वो सब मैनेज होता है
तो डिप्लॉयमेंट मीन्स दिस कि कितने पॉड्स बनाने हैं, कंटेनर इमेज टू बी यूज्ड, कौन सा कंटेनर इमेज यूज होगा और उसका अटैच स्टोरेज क्या होगा, राइट? ये सब हम डिफाइन करेंगे. डिप्लॉयमेंट्स आर टिपिकली क्रिएटेड मैनेज्ड विद kubectl create or kubectl apply command. Create a deployment by defining a manifest file in the YAML format. Like manifest file बनानी पड़ती है YAML format deployment के लिए, right? Then we have namespace. A case cluster. Namespace क्या होता है बोलो? What is namespace?
ये इसके अंदर नेम स्पेसिफाई करना पड़ता है जो भी पॉड के लिए तो एक नेम स्पेसिफाई करना पड़ता है
क्या करना पड़ता है? Namespace
और
क्या करना?
जैसे कि फॉर एग्जांपल नेम स्पेस के अंदर कौन से कितने हम लोग एप्लीकेशन है पॉड के अंदर इंस्टेंस जो रहेगा तो हम लोग वो नेम स्पेस के अंदर ही यूज कर सकते हैं जैसे में बाय डिफॉल्ट एक होता है डिफॉल्ट एक होता है उसके अंदर अगर हम उसको नेम नहीं देंगे नहीं तो बाय डिफॉल्ट वो डिफॉल्ट के अंदर वो इंस्टेंस पॉड के क्रिएट होता है तो हम कभी इसमें सर्च करेंगे क्यूब सीटीएल से तो वो नेम लेके पॉड का और उसके इंफॉर्मेशन क्यूब क्यूब सीटीएल गेट पॉड तो जितने भी पॉड रहेगा वो बाय डिफॉल्ट वो सब दिखाएगा और फिर अगर उसको चेक करना है तो उसके लॉग्स भी चेक कर सकते हो उसका नेम लेके
Namespace में क्या होता है? Sometimes the names can repeat. Namespace is like for avoiding the repeating for the administration also. ये हमने कुछ resources ये namespace में बनाया, कुछ इसमें बनाया, right? तो that's the reason namespace इसके लिए होता है. इससे हम restriction भी कर सकते हैं.
कैटेगरी टाइप में रहता है वो एक डिफॉल्ट डालेंगे तो उसमें सब डिफॉल्ट है कोई भी नेम डालेंगे उसमें स्पेसिफाई करना पड़ता है डिफॉल्ट रखना है जब भी हम
For example, you have cube system namespace and engineering namespace. So engineering users को यहाँ पर access दिया है और admin users को इधर access दिया है. So if you create a namespace in the cluster, then resources can be organized as per the namespace and you can give the permissions. उसके लिए होता है namespace. Troubleshooting के लिए नहीं. Namespace is used for giving the permissions. See what are namespaces? Kubernetes resources such as pods and deployments are logically grouped into namespace to divide AKS cluster and restrict, create, view and manage access to resources. उसके लिए रहता है. आप namespace बना के आप उसको permission दोगे. For example, you create namespace to separate business groups. Users can only interact with the resources within their assigned namespace. ठीक है तो ये सब Kubernetes का हमने देखा आज. Okay guys, got it? Hello, Sanjay.
Yes, Manoj.
Yes, sir. Sir, we don't have all these sheets actually with us. I don't have it.
Yeah, it's there with you, my dear. It's there in your notes.
जो बैकअप्स
Uh, I'll check it out actually because I am not sure that I have it. I
Just
have
check.
some parts of.
Don't have, I'll
yeah,
give you.
I'll check.
I told you, everything
Thank
is
you,
yours
dear.
except my heart. That I have
Thank you,
given
dear.
to someone. Everything else is yours. Take it.
Thank
wow
you. Thank you, dear sir. Thank you, dear sir. Thank you.
Thank you.
Yes,
Thank
sir.
you. Thank you. Thank you.
Thank you.
Thank you.
I know that you are copying me right now. I think so.
What?
I know you are copying me actually. I'm just making like I'm doing.
I'm copying you. Yeah. What to do, man? I'm just like that. You know that. You know me now very well now. No.
I know.
I think you can act like me also now, right?
Yeah, I know. I do act like you sometimes. I start laughing. Uh,
To do it's just I'm I go a little crazy sometimes. Crazy.
क्लास इज ओवर
Wait, no man. Wait, no. Where you want to go? Where you want to go?
प्रोडक्शन पे काम
Little.
You're only earning the money, not giving the party also. Party. You're doing lot of work, you're having lot of money. You give party to serve to the colleagues. Right or not, sir?
Absolutely.
अरे बाप रे यार क्या बोलता पार्टी में क्या बोलता the choice is not harsh. Not harsh means that you have क्या है tell. रास्ता मत बोलना मुझे भी बोल ये बात ही नहीं है प्रॉपर्टी ये प्रॉपर्टी बोल okay we'll have yes bring some sweet huh? Bring some sweets on sweets bring that salsa you know that oh जो इसका मिठाई मीठा वो तुम्हें मां उस्मान पता है कौन सा वाला उसका वो फूल
Okay, guys. So I'll see you next class. Okay.
Thank you, everyone.
Yes, Manoj, we'll meet on Friday.
Thank you very much.
Thank you, guys.
And
Yes.
thank you so much
Thank you. Thank you. Thank you.